Hello. Today we're going to do 1-6 modeling real world data with linear functions, and we're going to do 1-7 piecewise functions. Okay. Alrighty. So we're going to start in your book. If you could open up to page 38, or you can look along with me. We're going to talk about data in the real world and how it looks. Okay. So right here. If you remember drawing scatter plots, so putting your scatter data onto a plot and drawing regression lines or best fit lines. I know you did this last year. Okay. And creating prediction equations. Right. I'm gonna talk about how you can create a prediction equation on your own. And then we're also going to talk about how we can actually do that on our calculator. It's really awesome. All right. So some things that our scatter plot can show us is two different types of relationships. We can either have a positive correlation relationship, so where all of our data is pretty close together and going in a positive direction. We can also have a negative linear relationship with our data is fairly close together in a negative direction. Or we can have no pattern or no correlation relationship when our data is kind of all over the place. Okay. Whoops, knock something off the desk. All right, the other thing that for your homework tonight, I wouldn't write this down, just take a peek. It's on page 40. Talks about different correlations and correlation coefficients. All right. So this relationship here, we would say that it is a positive correlation because you can tell they're heading in the positive direction, but it's fairly spread out. So it's going to be a weak relationship. Anything with an R or a correlation coefficient, it'll give you it on your calculator too, we can take a look, but between 0 and 0.5 you're gonna say is weak. Okay, and we'll know it's positive because it's positive. All right, this data here, we notice it's going the positive direction, but it's kind of spread out. It's not super tight together, so it would be between 0.5 and 0.75, and that's going to be a moderately positive. Okay, and then a strong positive is when we have data pretty together and it's in pretty much one straight line. It'll be a 0.75 to a 1. And then the numbers work the same but with negative. So if something's in the negative direction, it's between 0 and negative 0.5. We're going to say that it's negative and weak. This one's going to be moderative and negative, and this is going to be a strong negative. All right, so let's talk about making these. Okay, so if you're going to do a linear regression on your own, making your own, here, I'll just show you really quick in the book. There's a great example. You can take a look at it if you want to. Okay, so what they did is they plotted some data from somewhere out beginning of the lesson. Okay, to make a line of best fit for it, we choose 2 points that seem to make a line the best between it, and we find the slope of our line. Okay, so this was our slope. Then we're going to use an ordered pair to plug that in and find an equation with a b. All right, so just what we did last lesson, but now it's going to be a line of best fit. We also can do this on the calculator. Okay, so linear regression on a calculator. So we're going to go through it. I pull your calculator out and walk through the steps with us. I'll show them to you on my calculator as well. Okay. All right, so first thing we're going to do is we are going to enter our data into the calculator table. We're going to turn on our scatter plot. I'm not even going to read it to you. I'm going to show you this first, okay? And then we'll do it together. All right, so what we're going to do is step 1. Here's my data. Okay, the question is can we find what personal consumption happens in the year 2010. Okay, let's write an equation and find that. All right. So the directions tell us to graph the data on a scatter plot. Oh goodness, I wrote it all. So first direction would be to graph the data on a scatter plot. So instead of doing it by hand, I'm going to show you the magic of our calculators. Okay? All right, so you're going to push stat, and you're going to push enter on edit, and it's going to give you a table. And you're going to plug these numbers in. So this right here, that's your x's, or we're going to also say that that is L1, and this bottom line is going to be L2. Okay? So we're going to start with our L1s, 1995, 1996, 1997, 1998. Hey, you got to be careful with these. These, if you input a number wrong, it's going to give you the wrong equation. I'm really good at putting the wrong number in. 2002, and then 2010 is our last one. So if you have anything else in your calculator, just delete it out. I had some extra rows because we were doing some linear regression in calculus. Yep, you'll see this again. All right, so then enter these: 2294, 2420, 2538, 2717, 2927, 3057, 3088, 3158. Done. Okay, so there's step one. Enter your data. All right. The next thing we're going to do is we're going to turn on our scatter plot. So we're going to go second stat plot. Okay, wherever that is on your calculator, you want to hit stat plot. We are going to do the first one. We need to turn our plot on. So we're going to go enter. We're going to turn it on. We want our type to be scatter, so make sure it's picked the scatter plot. Our X list is going to be L1 because that's where we put it. Y list is L2. We'll have the mark be a little square. You can pick whatever one you want. Okay. And now you can push graph. Ah! My calculator is doing all sorts of things. So now what I need to do is I need to go to my Y and clear out something that's in there. Okay. And then it wasn't showing up, so I need to go to my window. My X's are from 1995, so I might need to pick something else a lot closer. So maybe I go from 1990 to 2015, just because we're going to use that eventually. We could go by 5s, pick something. Okay, -2. Nope, that's not going to work. We're at 2294, so let's go maybe 2200 to, we want to know what happens after that, 3500. Maybe we'll go by hundreds and push graph. So there we go. Isn't that really cool? It gave us a scatter plot. Okay. Where it says graph the data on the scatter plot, I am good if you write on calculator. Okay, I don't need to see your scatter plot. If you know how to do it, I'm good with that. Okay. All right. This is going to ask us to use 2 ordered pairs to write the equation of the best fit line. Okay, so we could legitimately just pick 2 of the pairs. So maybe it looks like this 95 and maybe this one. It's our second. Okay, you can pick whatever order pairs you want. I liked this one, so I'm going to use 1995 and 2294. And the one I picked was 2001 and 3088. Okay. All right, so this is what I was talking about, being able to do it on your own. So we want to write an equation of best fit, which means we want y equals mx plus b, which we need to find then an m, and we need to find a b. So let's start with an m. This is where we're going to do y2 minus y1 over x2 over x1. Okay, I'm going to get my calculator out. No thanks, doing that in my head. Minus 794 over 6. Okay, we're going to actually find out what 794 minus divided by 6 is, so we'll say 132.3. So that's our m. X plus b. Now I'm just going to use one of my points, doesn't matter which one. I'll use this one because there's no reason. Use the other one if you want. Okay, now I'm going to solve. Oh, whew, I gave myself enough room. Okay, 132.3 times 2001. 264,799 plus b equals this. Okay, I'm going to subtract this from both sides. And I'm going to get that my b equals 2,61711. So I'm going to plug that back up here to get my equation. Y equals 132.3x plus 261711. Okay, that'll be my answer for line of best fit. All right. Your answer isn't going to necessarily fit the book one because they pick something different, and that's okay. All right. Okay, ballpark. It's okay on here. All right, next part. Use a graphing calculator to find an equation of the regression line and what is the correlation coefficient. So sweet. This goes back to our calculator. Okay. So to get an equation, we're going to push stat. We're going to go over to calc. And now we're going to go down and pick linear regression, ax plus b. That looks like our slope-intercept form. We'll push enter and enter. And it is going to give us a linear regression equation. Did I do this wrong down here? Yes, I did. It should be a negative because we did here and there. So this should be a negative. Okay, look at that. I caught myself. Okay, so down here, it tells find the equation. So it tells us that this A goes in here for AX and the B goes in the end. So my equation on my calculator says 132.8x. I was going to round it to 2 decimals, but that's not going to work. So 8x minus 2621.2. Okay, if we look, we're pretty close. Not bad. Look how close our slope was. That's pretty impressive. Okay, and then it wants the correlation coefficient, which is going to be RR, which is approximately 0.98. That's what I was talking about with the, this. Well, here we go. So if the equation of the regression line shows a moderate or strong relationship, predict the missing value. So our R is 0.98. So you're going to take a look in the book. I'm going to pull it out for you. So 0.98 would fit right here. So that's strong. So our data actually showed a very strong positive relationship. Okay. So we had a strong relationship. So that means that we can predict the missing value. So we're going to put 2010 into our equation. To get an answer to approximate what it would be in 2010. Okay, it's kind of fun to be able to do it with your calculator. Also, to point out, I didn't change my years to make them 0, 1, 2, 3, 4, 5 because it actually made this, we can just plug it straight in. It's kind of nice. Okay, so we got 4306, 80, 4306.80. This is in money. 0.8. Okay. So there we go. That'd be our answer. So in 2010, our personal consumption expenditures would be about 4306.80 if this data gives us an estimate, if it continues to be linear. Okay. All right, awesome. You may need to make your own, but I know that you will be able to try out your skills using your calculators. All right, second part of our lesson is on piecewise functions. I know you also did this last year. So reminder for you, a piecewise function, they're created by different equations for different intervals. The pieces can touch each other or they do not have to, all right? So when you do your piecewise, think of them in pieces. That's why they're called piecewise, okay? So it's gonna tell you intervals. Really good idea to use a pencil if you need to erase, okay? I wanna remind you that something with a line under it will have a filled in dot. Something without a line will have a circle, so an empty dot. So we're talking about when x equals -2 and over, less than -2. So y equals 1. Remember, this equation is when y equals 1. Y is going to equal 1 always, right here. Okay. But we just want it when it's less than -2, 1, 2. So we're going to erase everything from here over. Okay, that's why I did an erase in my pencil. So that's the first one. I'm going to just check it off that I did it. First piece done. Next piece is between -2 and 3. So let's graph the equation and then we can move it around. Okay, so my y-intercept is 2. My slope is 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, I want it from -2. It's not going to include -2, so this is my spot -2, so I'm going to put a hole here. And I want it to go all the way to x is 3. 1, 2, 3. 3, 3, and I want it to include 3, so I'm going to draw this line. So check. Last piece. Now I want to do an x is greater than 3, and I'm going to use this equation of 2x. So I'm going to start at 0. I'm going to go up 2 over 2. Up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1. But I only want this line when x is greater than 3. 1, 2, 3. And it's greater than, not equal to, so I'm going to draw a circle here. Oh, my circle filled itself in. So I'm going to erase. And I only want greater than 3, so I'm going to just draw my line here. Arrows. I'm going to go back through and erase any of my dots I made. Okay, and I'm done there. So each one of them, do them in pieces. Write out the line, then erase what you don't need. Okay, piecewise function. Okay. This symbol is the greatest integer function, not greater than x. Okay, so I'm going to look on page 46 so we can just chat about it. Okay, so it tells you to graph the greatest integer function. Okay. So what we're saying is that it's not greater than 0. It's an integer, so it can't be a line. So from here to here, it can't be equal to 0, but when it gets to 1, it's always equal to 1. then it goes up, always equal to 2. Okay, so that's our greatest integer function. I want you to know what it looks like and how to graph it in case you need to graph it. Okay. I want to show you some things over here. Greatest integer function, here's another example. If you multiply it by 3, you would just, every integer, you would go up 3, because now if you plugged in a 1 here, 3 times 1 would be 1. 3 times 1 would be 3. So it would be that length for the next integer. So just an idea to give you a picture. I'm not sure I don't remember what's on your assignment for that. Okay, but if you need a reminder, you can just peek in your book. All right, absolute value. Last thing. Absolute value is a piecewise function. Okay, I'm going to show you. Let's just do it. All right, so here's your absolute value function. I'm really excited that this pencil works and you guys can see it. Last year we couldn't see the pencil very well, so I'd use pen. Okay, absolute value is our v function, and absolute value is a piecewise function. So we're going to create the piecewise for this. Okay. I don't know if it has you actually create piecewises, but if you do, here you go. Here's a great example of it for you. Okay. All right. So let's start here, from here to here. So when x is less than or equal to 0, right, and our other side is x is greater than or equal to 0. So now we got to make 2 rules. Okay. So for on this side, we go up 1, negative 1, up 1, negative 1. So we start at 0. So that is, let's see, we'll say this is y equals negative 1x plus 0, or y equals negative x. So we're going to put a negative x right here. And on this side, we go up 1 over 1. So 1x, and we start at 0. So y equals x. So the directions to make a absolute value is actually a piecewise. Fun fact for you. All right. Here is your homework. All answers should be posted in Classroom. Please reach out if you have any questions, and have a great week.